This video is going to discuss the class of organic compounds called alkanes. These are compounds that contain carbon, hydrogen, or carbon atoms and hydrogen atoms, and only single bonds. So they will have formulas of C something, H something. And today we're going to learn something about how we can predict the formulas of the alkanes. So let's start with one carbon, and remembering the rule that carbons have to have 4 bonds or 4 valences. Predict how many hydrogens there would be if we start with 1 carbon. Obviously the answer is 4. To make 4 bonds to carbon, we would need 4 hydrogens. Thus the formula for that alkane, and again it's an alkane because it has only carbons and hydrogens and only single bonds, would be CH4. That's a prediction we make. In fact, it has been found that there is a compound with the formula CH4, and it is called methane, and it has certain properties. The properties are that it's a colorless, odorless gas, very flammable. It has a density of 0.714 grams per liter and condenses down to a liquid if you cool it down to negative 164 degrees centigrade. In fact, you've seen that compound before. It's the main part of natural gas, which is what we use in Bunsen burners in the lab, and also probably you may use it in your home to cook your food and or heat your home if you heat with natural gas. Okay, let's do another example. How many hydrogens would we expect if there are 2 carbons? The answer is 6, because each carbon has to have 4 hydrogens. That would then have the formula C2H6. And by the way, let me show you a model of the first one, methane. This is what 1 carbon and 4 hydrogens would look like. Again, that's methane or CH4. By the way, is there any other way of drawing it than that right there? And would it give us a different compound perhaps if we draw it in a different way? Well, you might consider, what if we make it in an X shape? Is that a different compound? And the answer is clearly no. This is the only way that we can arrange 1 carbon and 4 hydrogens. So it's not a different way of drawing it. It's not a different formula. They're both legitimate ways of drawing it. It's just that they're not different from each other. So we'll just draw it with one way of drawing it. And by the way, that was methane. Let's look at the model of ethane. Here's a model of ethane. Does it look like that? Well, not exactly, but it represents 2 carbons with 3 hydrogens on each for a total of 6 hydrogens. Is there any other way of drawing that? Well, we could draw it up and down instead of side to side. Does that change the structure? No. We could perhaps make the hydrogens going out at an angle. Does that change the structure? No, it's still just a structure. That, by the way, is a compound called ethane. And it also has been found to be an actual compound, and it has certain properties. Again, it's a colorless, odorless gas. It's also found in natural gas. But unlike methane, it has a density of 1.34 grams per liter and condenses to a liquid at only negative 89 degrees centigrade. So, as you might expect, it's more dense, and it also has a higher boiling point, so to speak. By the way, you might want to think about why would we expect it to be denser, and why would we expect it to have a higher boiling point. Those both have to do with intermolecular forces, and you might want to think about that in terms of general chemistry, but we won't deal with that right now. Let's go on to the next example. Can you predict how many hydrogens should we have for 3 carbons? 3 carbons have to be attached to each other in that way. Now, by the way, we could draw them around a corner, but it turns out not a different compound. How many hydrogens would we expect there? The obvious answer is 8. 1, 2, 3, 4, 5, 6, 7, 8. Drawing making sure that each carbon has 4 bonds, and putting in the hydrogens. That would be the formula C3H8. And by the way, that also can be shown in a model. Notice that it has to be bent, can't actually be straight across as the Lewis dot structure suggests, but it does in fact have 3 hydrogens on this one, 2 hydrogens on this one, 3 hydrogens on this one, for a total of 8 hydrogens. That also, it turns out to be a real compound, and there is a compound that has a formula C3H8. It's called propane, and it has certain properties, some similar to the other 2 gases we've talked about, some different. You've probably heard of propane. It is, as I said, a real compound, and it is often used to heat homes out in the country where natural gas lines don't run. Perhaps you've used it to grill if you have a gas grill that uses propane. Also has a density of 1.96 grams per liter, again quite a bit higher than the other 2, and it condenses at only negative 42 degrees centigrade, in other words a higher boiling point as you might expect. Okay, now I'm going to have you do some thinking about this, and then next, when we come to class next time, we will talk about it. I would like you to notice that the formulas so far are C1H4, C2H6, C3H8. Predict what will be the formula for a C4 alkane, and furthermore for a C5 alkane. How many hydrogens would that have, and how many hydrogens would that have? And can you come up with a mathematical formula that will allow you to predict how many hydrogens would you have? For example, if there was a C21 alkane, how many hydrogens would it have? Or a C135, how many hydrogens would it have? There is a way of predicting it, and you don't have to go through each example in order to do that. We'll come up with a mathematical formula, and I would like you to think about what is that formula. Furthermore, when you get to 4 carbons, I've drawn a structure, I made a model of it, and you can, if you count quickly, see how many hydrogens there are. But what I'd like you to think about is, if you draw the C4 alkane with as many hydrogens as it has, is there any other way of drawing 4 carbons with the same number of hydrogens? And we'll talk about that in class next time.